Okay, let's finish that. Let me see if I can draw a line here. That's a big line here. Okay, so there's that example. And to make clear where our points were, since that's such a big line, we had a point there, and then we had another point up here. Okay. All right, let's change colors and take a look at example 3. Again, we have x1, y1, and x2, y2. So we're going to do -3 minus -3 all over 8 minus 4. Well, -3 minus -3 is the same as -3 plus 3, which gives us 0. And 8 minus 4 is 4. 0 divided by 4 simplifies to 0. Zero slope means it's going to be a horizontal line. And if we plot these points, you would see that. So 4, -3 is here, and 8, -3 is here. And I can do a horizontal line a tad bit better. But you could see that that is a horizontal line. So zero slope is a horizontal line. You can almost even picture it too. If you were just walking across a floor, a flat floor, you wouldn't be going uphill or you wouldn't be going downhill. You'd be going zero slope. Whereas in our blue line here, if we were to go left to right, we would be going up a hill, which is positive slope. Okay. And example 4, let's switch to green. Okay, so again, here we have x1, y1, and x2, y2. So we'll do -5 minus -1 over -4 minus -4. Well, -5 plus 1 is -4. -4 plus 4 is 0. Oh, watch out. Remember, when we have 0 in a denominator, we cannot have that. This means that this slope is undefined. Undefined. And when we put that on our graph, let's look at what it looks like. -4, -1 is here. -4, -5 is here. So this gives us a vertical line. And if you picture yourself trying to walk up a vertical line, unless you're Spider-Man, you can't do it. It's impossible. We can't walk up walls. And so that's a way to think of that vertical lines have undefined slope. It's just impossible. We can't do it. Okay? So those are the 4 types of slope that you're going to get. A positive slope, a negative slope, zero slope, or undefined slope. Okay? Now, would it matter? Here's a question for you. Would it matter if I chose this to be my second point and this to be my first point? No. In any of these situations, I could have reversed those ordered pairs and it would not matter. I would end up with the exact same slope. Okay, so know that you can kind of pick which one is your first one and which one is your second one. Last example, what if they don't give you both ordered pairs, but they do give you the slope? Well, so this would be x1, y1. This would be x2, y2. So we would do 4 minus r over 3 minus 10, and that would have to equal -2/7. Okay. Well, we can simplify this a little bit. So 4 minus r, 3 minus 10 is -7, equals -2/7. And now we can use cross products to solve this because it's a proportion. We had one ratio set equal to another ratio, so that's a proportion. So I'm going to do 7 times 4 minus r equals -2 times -7. That gives me 28 minus 7r equals 14. Subtract 28 on both sides, and I get -7r equals -14. Divide by -7, and we get r equals 2. So the missing coordinate there would be 2, and that would give us a slope of -2/7. Now, one way to help you remember those special case lines, the horizontal and vertical lines, is to use what we call Hooivaks. Hooivaks is just an expression that helps us to remember this. And so we could say horizontal lines have 0 slope with y equals a number equations. So for example, y equals 3. That would be a horizontal line crossing the y-axis at 3, and that would be 0 slope. And then vux would be vertical lines have undefined slope with x equals a number equations. So for example, x equals 2. That means it's a vertical line crossing the x-axis at 2. Pretend I can draw straighter than I can. And that's undefined because we can't walk up it like Spider-Man. So there you go. There's a lesson about slope and rate of change, and we'll practice this in class tomorrow. Have a great night.